Welcome to ISINMT, Information Management Module 3, Databases and Information Management. Knowledge management is the process of creating, sharing, using, and managing the knowledge and information of an organization. It refers to a multidisciplinary approach to achieve organizational objectives by making the best use of knowledge. Knowledge management is a discipline that promotes an integrated approach to identifying, capturing, evaluating, retrieving, and sharing all of an enterprise information assets. These assets may include databases, documents, policies, procedures, and previously uncaptured expertise and experience in individual workers. The concept and the terminology of knowledge management sprouted within the management consulting community. When the internet arose, those organizations quickly realized that an intranet or in-house subset of the internet was a wonderful tool with which to make information accessible and to share it among the geographically dispersed units of their organizations. Not surprisingly, they quickly realized that in building tools and techniques such as dashboards, expertise locators, and best practice databases, they had acquired an expertise which was in effect a new product that they could market to other organizations, particularly to organizations which were large, complex, and dispersed. Graphic map of knowledge management. A knowledge map is a technique that increasing efficiency of an explaining associations of knowledge bodies with the purpose of managing knowledge in an organization by creating similar content associations. The most commonly used algorithm is the prediction using association rules. However, this technique sometimes produce unsatisfactory results because the retrieved information hardly met the demand and could not explain associations of information contents to users deriving in less accessibility to knowledge. Transaction processing. It is the collection of different interrelated tasks and processes that must work in sync to finish an overall business process transaction. Transaction processing is information processing in computer science that is divided into individual, indivisible operations called transactions. Each transaction must succeed or fail as a complete unit. It can never be only partially complete. What about transactions in database management system? From the database point of view, the implementation of an application program can be considered as one or more transactions with non-database processing working in between. Transaction process is a term that refers to the adding, changing, deleting, or looking up of a record in a data file or database by entering the data at a terminal or workstation. Most transaction processing systems also include a method of ensuring that all the information entered as a transaction is simultaneously saved. When a large number of transactions are taken and then stored to be dealt with a later time, the process is known as batch processing. Different examples of transaction processing include automated teller machines, credit card authorizations, online bill payments, self-checkout stations at grocery stores, the trading of stocks over the internet, and various other forms of electronic commerce. Concurrency control in database management system. Concurrency control is the procedure in database management system for managing simultaneous operations without conflicting with each other. Concurrent access is quite easy if all users are just reading the data. There is no way they can interfere with one another. Though for any practical database would have a mix of reading and write operations, and hence the concurrency is a challenge. Concurrency control is used to address such conflicts which mostly occur with a multi-user system. It helps you to make sure that database transactions are performed concurrently without violating the integrity of respective databases. Therefore, concurrency control is a most important element for the proper functioning of a system where two or multiple database transactions that require access to the same data are executed simultaneously. The need for concurrency control. If transactions are executed serially, that is in terms of sequential, with no overlap in time, no transaction concurrency exists. However, if concurrent transaction with interleaving operations are allowed in an uncontrolled manner, some unexpected, undesirable result may occur, such as the lost update problem. A second transaction writes a second value of a data item or datum on top of a first value written by a first concurrent transaction, and the first value is lost to other transactions running concurrently which need, by their precedence, to read the first value. The transactions that have read the wrong value end with incorrect results. Next, the dirty read problem. Transactions read a value written by a transaction that has been later aborted. This value disappears from the database upon abort and should not have been read by any transaction. The reading transactions end with incorrect results. Next, the incorrect summary problem. While one transaction takes a summary over the values of all the instances of a repeated data item, a second transaction updates some instances of that data item. The resulting summary does not reflect a correct result for any, for example, usually needed for correctness in terms of the precedence order between the two transactions, if one is executed before the other, but rather some random result depending on the timing of the updates and whether certain update results have been included in the summary or not. We have the lock-based protocol. Lock-based protocols manage the order between the conflicting pairs among transactions at the time of execution. Database systems are equipped with lock-based protocols that is used as a mechanism by which any transaction cannot read or write data until it acquires an appropriate lock on it. So we have here the four types of lock protocols. We have simplistic lock protocol. We have the pre-claiming lock protocol, two-phase locking 2PL, and the strict two-phase locking. We are going to discuss each of these types of lock protocols. Let's start with simplistic lock protocol. It is the simplest way of locking the data while transaction. Simplistic lock-based protocols allow all the transactions to get the lock on the data before insert or delete or even update on it. It will unlock the data item after completing the transaction. We have the pre-claiming lock protocol. Pre-claiming lock protocols evaluate the transaction to list all the data items on which they need locks. Before initiating an execution of the transaction, it requests the database management system for all the lock on all those data items. If all the locks are granted, then this protocol allows the transaction to begin. When the transaction is completed, then it releases all the locks. If all the locks are not granted, then this protocol allows the transaction to roll back and wait until all the locks are granted. The two-phase locking 2PL. Two-phase locking has two phases. One is growing, where all the locks are being acquired by the transaction, and the second phase is shrinking, where the locks held by the transaction are being released. To claim an exclusive right or lock, a transaction must first acquire a shared or read lock and then upgrade it to an exclusive lock. Strict two-phase locking. The first phase of strict 2PL is similar to 2PL. In the first phase, after acquiring all the locks, the transaction continues to execute normally. The only difference between 2PL and strict 2PL is that strict 2PL does not release a lock after using it. Strict 2PL waits until the whole transaction to commit and then it releases all the locks at a time. Strict 2PL protocol does not have shrinking phase of lock release. Strict 2PL does not have cascading abort as 2PL does. Timestamp-based protocol. The timestamp ordering protocol is used to order the transactions based on their timestamps. The order of transaction is nothing but the ascending order of the transaction creation. The priority of the older transaction is higher, that's why it executes first. To determine the timestamp of the transaction, this protocol uses system time or logical counter. The lock-based protocol is used to manage the order between conflicting pairs among transactions at the execution time. But timestamp-based protocols start working as soon as a transaction is created. Let's assume there are two transactions. We have T1 and T2. Suppose the transaction T1 has entered the system at 007 times and transaction T2 has entered the system at 009 times. T1 has the higher priority, so it executes first as it is entered the system first. The timestamp ordering protocol also maintains the timestamp of the last read and write operation on a data. Data recovery in database management system. Data recovery is a process of salvaging inaccessible, lost, corrupted, damaged, or formatted data from secondary storage, removable media, or files when the data stored in them cannot be accessed in a usual way. Data recovery is the act of retrieving data from a storage device when the data turns inaccessible due to logical or physical failure of the device. Logical failure in accessing data from a storage device can occur due to accidental data deletion, drive formatting, volume deletion, drive corruption, boot failure, reinstallation of an operating system, and others. While physical failure can materialize on a storage medium owing to bad areas in the physical storage space, connectivity issue, component damage, electronic equipment malfunction, and others. Data recovery can be performed on a variety of storage devices, including internal storage drive of laptop or even desktop, external hard disk drive, solid-state drive, or even USB flash drive. We will also include optical storage medium and even memory card. Data recovery processes searches for the desired files in the storage device and retrieves them successfully. The toughness and strength of a system depend not only on the complex and secured architecture of a system, but also in the way how data are managed and maintained in the worst cases. If the underlying architecture fails or crashes, then there must be some techniques and procedures by which the lost data during a transaction gets recovered. What is data recovery? Earlier, you have been given the concept of database recovery as a service that should be provided by all the database management system for ensuring that the database is dependable and remains in a consistent state in the presence of failures. In this context, dependability refers to both the flexibility of the database management system to various kinds of failure and its ability to recover from those failures. Causes of data loss. Due to hardware or software errors, the system crashes, which ultimately resulting in loss of main memory. Failures of media, such as head crashes or unreadable media, that results in the loss of portions of secondary storage. Carelessness or unintentional destruction of data or directories by operators or users, and damage or intentional corruption or hampering of data in terms of using malicious software or files, hardware or software facilities. So what are the benefits of data recovery? Data recovery is helpful in many ways, whether you are at home or in a professional setting. Your photos, videos, and voice recording amassed and saved on your computer or an external storage medium can't be recreated or relieved. Data recovery helps you get back those treasured digital memories. Your business critical documents, projects, developed softwares, and others can't be recreated easily if they are lost. Data recovery salvages such data and helps prevent monetary, business, and reputation loss. It helps recoup data loss, disasters, and ensures business continuity. Let's talk about security. Database security. Database security concerns the use of a broad range of information security to control and protect databases against compromises of their confidentiality, integrity, and availability. It involves various types or categories of controls such as technical, procedural, administrative, and physical. Security concerns will be relevant not only to the data resides in an organization's database. The breaking of security may harm other parts of the system, which may ultimately affect the database structure. Security risk to database systems. Unauthorized or unintended activity or misuse by authorized database users, database administrators, or network systems managers, or by unauthorized users. Malware infections causing incidents such as unauthorized access, leakage, or disclosure of personal or proprietary data, deletion of or damage to the data or programs, interruption or denial of authorized access to the database, attacks on other systems, and the unanticipated failure of database services. Overloads, performance constraints, and capacity issues resulting in the inability of authorized users to use databases as intended. Physical damage to database servers caused by computer room fires or floods, overheating, lightning, accidental liquid spills, static discharge, electronic breakdowns or equipment failures, and obsolescence. Design flaws and programming bugs in databases and the associated programs and systems, creating various security vulnerabilities, data loss or corruption, performance degradation, and others. Data corruption and or loss caused by the entry of invalid data or commands, mistakes in database or system administration processes, sabotage or criminal damage, and others. Access control. In the fields of physical security and information security, access control is the selective restriction of access to a place or other resource, while access management describes the process. The act of accessing may mean consuming, entering, or using. Permission to access a resource is called authorization. Discretionary access control. It grants the privileges or what we call access rights to users on different objects, including the capability to access specific data files, records, or fields in a specified mode, such as read, insert, delete, or update, or combination of these. In computer security, discretionary access control, or DAC or DAC, is a type of access control defined by the Trusted Computer System Evaluation Criteria as a means of restricting access to objects based on the identity of subjects and or groups to which they belong. The controls are discretionary in the sense that a subject with a certain access permission is capable of passing that permission to any other subject unless restrained by mandatory access control. A discretionary access control policy is a means of assigning access rights based on rules specified by users. The underlying philosophy in DAC is that subjects can determine who has access to their objects. Mandatory access control. It is used to enforce a multi-level security by classifying the data and even users into various security classes or even levels, and then implementing the appropriate security policy of the organization. Mandatory access control is a security strategy that restricts the ability individual resource owners have to grant or deny access to resource objects in a file system. MAC criteria are defined by the system administrator, strictly enforced by the operating system or our OS, or even security kernel, and are unable to be altered by end users. Often employed in government and military facilities, mandatory access control works by assigning a classification label to each file system object. Classification include confidential, secret, and top secret. Each user and device on the system is assigned a similar classification and clearance level. When a person or device tries to access a specific resource, the OS or security kernel will check the entity's credentials to determine whether access will be granted. While it is the most secure access control setting available, MAC requires a careful planning and continuous monitoring to keep all resource objects and users' classifications up to date. Database security. Fraud and financial crimes are a form of theft or larceny that occur when a person or entity takes money or property, or even uses them in an illicit manner, which they intend to gain a benefit from it. Identity theft and fraud usually refer to the same crime. Still, one could make the case that the fraud is the actual use of the stolen information for illicit gain. If a system suffers loss of confidentiality, then data has been disclosed to unauthorized individuals. This could be high-level secret or proprietary data, or simply data that someone wasn't authorized to see. Data privacy or information privacy is a branch of data security concerned with the proper handling of data, consent, notice, and regulatory obligations. More specifically, practical data privacy concerns often revolve around a loss of database integrity or consistency means that data are still present in a database but have become partly corrupted or unintelligible. As a result, the data cannot be correctly processed anymore. Data availability is about the timeliness and reliability of access to and use of data. It includes data accessibility. Availability has to do with the accessibility and continuity of information. Information with low availability concerns may be considered supplementary rather than necessary. Information with high availability concerns is considered critical and must be accessible in order to prevent negative impact. So what is a threat? So a threat may occur by a situation or event involving a person or the action or situations that are probably to bring harm to an organization and its database. Threats to the database can be numerous. The threat can be accidental or intentional. In either case, security of the database and the entire system, including the network, operating system, the physical area where the database resides, and the personnel allowed access must all be considered. So computer-based control, we have the access authorization. It is a process through which the operating system determines that a process has the right to execute on the system. The most common form of this control is the username, which we are all familiar with when we log on to a computer. The second form of operating systems protection is authentication. We also have access control. It is a security technique that regulates who or what can view or use resources in a computing environment. It is a fundamental concept in security that minimizes risk to the business or organization. There are two types of access control. We have the physical and the logical access control. We have the views. A view is a presentation of data selected from one or more tables, and possibly including other views. In addition to showing the selected data, a view may also show the structure of the underlying tables and can be thought of as the result of a stored query. Data backup and recovery. It is the process of backing up your data in the event of a loss and setting up secure systems that allows you to recover your data as a result. Data backup requires the copying and archiving of computer data to make it accessible in case of data corruption or deletion. Data integrity. It is the maintenance of and the assurance of the accuracy and consistency of data over its entire life cycle and is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. Data encryption. It translates data into another form or even code so that only people with access to a secret key, formally it is called a decryption key or a password, can read it. Encrypted data is commonly referred to as ciphertext, while unencrypted data is called plain text. And lastly, we have RAID. It is the redundant array of inexpensive disk. It is a data storage virtualization technology that combines multiple physical disk drive components into one or more logical units for the purpose of data redundancy, performance improvement, or even both. So this is the end of ISINMT Module 3. This also means that you are done with the Information Management course. Congratulations!